about this A here.
I'm still here.
I'm talking about this A that I circled. You see this A that I circled?
This A, no. Okay.
Yeah, find it for me. We are given f of x equals to
Equals to
ax, right?
Yes.
And remember, a has to be greater than 0, right?
Yes.
And then since, well, a lies on this equation of f of x, so we can use this point since, well, they are on the function, right? They're on top of this function, right?
Yes.
So let's substitute. Our y is 9, right?
Where did a greater than 0 go? Any part of the equation?
It's not part of the equation. It's comma. Remember, it's comma here. There is a comma.
I don't press a dot.
No, it's a comma.
Can I do it again?
Yeah, do it again. So what will be your final answer?
Which is 3.
It's 3. So our
A
a
equals to 3.
is equals to 3. So now we'll rewrite this function. Instead of writing a here, we can write 3. We can write 3 to the power of x. So function of x is 3 to the power of x, right?
Yes.
So now, I want you to do this question. Determine the values of x for which f of x will be equal to g of x.
X value.
Yeah, only the x value on the coordinate. What is the x value?
It's 2.
It's 2. So x equals to 2. So there's the other method. Right? So
Yes.
I want us to do the other method. This one it might need most of your attention because there's a lot of actually there are a lot of things that you don't know. I can't actually do, but let's do it. You might learn something in the future.
Okay.
You might learn something. So f of x equals to g of x. This method. So okay, we were given. So f of x is 3 to the power of x, right?
Yes.
And g of x is minus x plus 11, right?
Plus x.
This thing is 11 minus x. Are you with me?
Minus x.
Yeah, because the x is negative and the 11 is positive. Are you still there?
Yes.
Yes. I want us to write this thing as that. So now we'll divide both sides. We'll divide both sides by 3x. And even this side 3.
Yes.
So this side will remain with 1, right? Because 3
Yes.
11
11
minus x all over
x over 3.
3x, right?
Exponent x.
So now I'll take this 3 and put it as my numerator. So what will happen with the exponents? Are you with me? Are you still there?
Yes, I'm still here.
I'm removing this 3 to the power of x as a denominator. I'm putting it as the numerator. So now it's going to be something like 3 to the power of negative x. Remember, it was positive. When it becomes a numerator, it becomes negative, right?
No, it's negative.
Are you still there?
Still here.
Are you still following the procedure?
Yes.
Okay.
So
Now-
is it gonna be like x over? It's gonna be 1 equals to open bracket minus x close bracket times x over 3.
Now, this is the same as 1 over 3 to the power of x. Remember that, right?
Okay.
So now we change this to become an exponent. So this is 1. So remember, we can change. Remember, 3 to the power of 11 over 3 to the power of 11 is the same as 1, right? It's like 9 over 9. What is 9 over 9?
Equals and
equals to 1. So 3 to the power of 11 over 3 to the power of 11 is the same as 1. Are you still there? Bear with me. So this is 11 minus x and then times 3 to the power of negative x. So even the mouse is complaining. So yeah, this is long. So this is negative x. So now we are going to multiply both sides. Remember, we want to remove the denominator, right? Yeah, we want to remove the denominator. How can we remove the denominator? We can multiply all sides. We can multiply all sides by the denominator, right? By 3 to the power of 11 both sides, right? 3 exponent 11, right?
Yes.
So this one will cancel this one. Now, and also now this one actually will just disappear. And then on the left hand side we'll remove this one. So now we'll apply the law of indices. Remember, when you are multiplying with the same base, we add the exponents, right?
Yes.
So this will be, we'll write it as this one. It's going to be 11 minus x. Are you still there? And then open bracket 11 minus x. Are you still with me?
So, it is hard to.
Yeah, this one is very hard, bruh. That's why I wanted us to do the simple way. So now from here we're actually almost done, but
since, well, in this case we have 11 minus x 3 to the power of 11 minus x, we can change 11 3 to the power of 11. 3 to the power of 11 is the same as 3 to the power of 2 times 3 to the power of 9. So yeah, using the laws of indices, which is basically equals to that. And then we know that 3 to the power of 9 is the same as, 3 to the power of 2 is the same as 9, giving us 9 times 3 to the power of 9. And then 11 minus x, then 3 to the power of 11 minus x. And then we can see that we know that e, using the laws of logarithm, e to the exponent ln 3 is equals to 3. This implies that e actually cancels the logarithm, the ln, and then this implies that in this case we can see that we can actually use this law of logarithm. So we can just say, in the place of 3, we can just say e ln 3 to the power of 9. We eventually know that this is equal to 3 to the power of 9, and then we can also apply that on the right hand side, giving us 11 minus x e ln of 3 to the power of 11 minus x. And then we know that using the laws of logarithms, we can actually take this 9 and then putting it at the beginning of this logarithm, the beginning of ln, and also 11 minus x can be placed at that side. So let's just get into that. We can rewrite this as 9 e to the power of 9 ln of 3. And then the same thing applies on the right hand side. We can say equals to 11 minus x, and then e to the power of 11 minus x ln 3. So now there's this trick that we want to use. Remember, what you do on the left hand side, you have to do it on the right hand side. So we want to have ln 3 on the left hand side and also ln 3 on the right hand side, so that the numerators and the denominators can be the same. So in this place, we're going to multiply by ln 3 both sides. So let's get into that. So we're going to say 9 times ln 3. Remember, what you do on the left hand side, you have to do it on the what you do on the left hand side, you have to do it on the right hand side. Also this side, we can say 11 minus x ln 3. So eventually here we know that this is e to the power of 9 ln 3. And then also this side is e to the power of 11 minus x ln 3. So now we can see that, okay, the exponents the basis before e, it's actually the same as the exponent, right? And also the right hand side, the base there, 11, we have 11 minus x ln 3, and also in the numerator we have. So what happens next? Now we are going to equate. You have to choose either you equate the exponents or you equate the basis before e. So I'll choose the basis. I'll say, okay, it's either you choose the basis or you choose the exponent. So both methods work. Remember, they are both equal. So now I'm going to say 9 ln 3. So I'm equating the exponents. 9 ln 3 equals to 11 minus x ln 3. So I'm going to divide both sides by ln 3. So divide both sides by ln 3. And then the lns actually cancel. We'll be remaining with 9 equals to 11 minus x. So we can just solve for x. Take the x to the left and the 9 to the right hand side, giving us. So remember, if you take x to the left hand side, it becomes positive, and 9 to the right hand side, it becomes negative, giving us x equals to. And that giving us 11 minus x. Therefore, x will be equals to 2.